All right, let's talk about net ionic equations. Three basic rules that we're going to use. Write out the equation for the reaction, identify the solid, write the ionic equation, then balance each side, and write the net ionic equation. So we'll talk about what all these things mean. And we'll do this through examples. So an example here, what is the net ionic equation when you mix lead 2 nitrate, which is PbNO3 and potassium iodide, which is Ki, to make lead 2 iodide and PbI2, which is a yellow solid. And this picture over here on the right shows what that mixture looks like. You can see the yellow, that's the precipitate or the solid that's made when you mix these two aqueous solutions. Keep in mind what we're doing is we're taking two things that are basically substances, in water, aqueous solutions, mixing them together, and we will get a solid precipitate. In this case, it's yellow lead 2 iodide. So the first thing is, what's the chemical reaction that we're looking at here, the chemical equation? We're taking PbNO3, we're taking that lead nitrate, we're mixing it with Ki, or potassium iodide, and we're making PbI2, or lead 2 iodide. They tell us that. They tell us that we're making PbI2. The thing you might have to figure out is what's the other thing that's made. In this case, it's KNO3. You can kind of do that just by looking at what they give you and looking at what's supposed to be made and trying to figure out what's left over. So in this case, they tell us we're taking this lead nitrate that's given to us. They tell us that in the question. We're taking Ki, or the potassium iodide, and then they tell us we're making PbI2. So those are all things they told us in the question. PbNO3, Ki, PbI2. We're going to make PbI2. So we're making, try to make an arrow here. We're making PbI2. So what's left over? Well, we used up Pb and I. So Pb and I. We got K and NO3. So that's how you know what this other substance made is. All these reactions that involve ionic equations, they're always double displacement or double replacement reactions. What that means is you're going to have two substances combined, you're going to have a switch occur where you make two different substances. So we take the lead, we take the Pb, NO3, we mix it with K and I. The Pb goes over to the I, and the K goes over to the NO. That's a double displacement or double replacement reaction. So that's kind of the things you want to think about for how you would write out the actual chemical equation. You'll also want to balance it. So writing out the chemical equation is one step. I already balanced this one. We got 2 Ki, we got 2 KNO3. Balancing is obviously something very important, or a very important part of chemical equations. So make sure to do that also. So let's look at the next step. So now we got the chemical equation. We want to identify the solid. The solid in this case is PbI2. Basically, don't mess with the solid. The solid is that yellow stuff that's made. It's not going to be broken down or anything. It's making, one of the whole point of these type of reactions and understanding them is that you're understanding what solid is made. So this is basically the most important thing out of this whole reaction here, is that that solid is made. Now, something called the ionic equation can be figured out by using the chemical equation. And it's basically just breaking up each elemental ion. So PbNO3, break it up to Pb plus NO3. In this chemical, or in this ionic equation, we put a 2 here because there's a 2 up here. There's 2 NO3s. So we put a 2 when we're trying to break down the ion. We look at Ki next. We got potassium and iodine. So we have potassium plus iodine. There's 2 of each too. It's 2 Ki, so we put 2K and 2I. The other side of the reaction, we're not going to mess with the solid, so the solid stays the same. But we can break up the potassium in the NO3. So we get 2K because we had a 2 up here. And we get 2 NO3s because we had a 2 up here. 2Ks, 2 NO3s. So that's what the ionic equation look like. You're just breaking up each element into its singular ion. Chemical equation, now the ionic equation. Looking at it again, we can take the ionic equation, we can figure out what the net ionic equation is by eliminating elements that are on both sides of this reaction. And that's what I did here. We had NO3 on both sides, so I crossed them out. They basically cancel each other out. We had potassium, 2 potassiums on each side, so they cancel out. What we're left with is basically the net ionic equation. We have lead, aqueous lead. We have iodide, aqueous iodide. And then the solid that we didn't mess with. So Pb plus I gives you PbI. And that's your net ionic equation right there. There's your answer. So these are the steps you want to follow when you're doing a problem like this. Figure out what the chemical equation is. And the problems that we're going to do, I'll give you lots of hints that'll make it easier to figure out what the chemical equation is. See if you can figure out the total ionic equation. Cancel out what's on each side of the arrow, and then get the net ionic equation. Let's try another one. Show the net ionic equation when you mix potassium sulfate, which is K2SO4, with barium nitrate, BaNO3, to create solid barium sulfate precipitate. So first, write out the equation, write out the whole chemical reaction, or the chemical equation, and then kind of spot the solid. So I told you up here in this example, this simple example up here, K2SO4 combined with BaNO3. So that plus that. They're both aqueous. Again, the whole point of reactions that involve net ionic equations is you're taking two aqueous solutions. You can see aqueous is down here. And we're reacting them to get some type of precipitate or a solid made. And then we have something left over. So in this example, this very straightforward example here, we have 3 out of the 4 things. You just have to figure out that KNO3 is the other substance made on the product side. We have the solid, that's BaSO4. We are told what the solid precipitate is. Now write the ionic equation, the total ionic equation. Here's how I wrote this one here. Again, you're just splitting up each element into its singular ion. So K2SO4 becomes 2K plus. It's K plus because potassium is positive. Use the periodic table to help you with that. SO4, minus 2. There's only one of them, but it's a minus 2 ion. Sulfate's a minus 2 ion. Next, we have Ba and NO3, so we get BaNO3. There's a 2 up here, so it's 2NO3. On the other side, we got 2 potassiums over here, so 2 potassiums. We'll also have 2 nitrates, so you can see there's 2 nitrates. And then BaSO4, we don't separate that because it's the solid made. We can cross out the things that are redundant. There's 2 potassiums on each side, so we cross those out. See, I already did it here. There's 2 NO3s on each side, so those get crossed out. So take a second and think about what is the net ionic equation here. It's very simple. SO4 plus Ba makes BaSO4 solid. Something to notice, the net ionic equation is the thing that's showing what's combining to make that specific solid. We're combining barium and sulfate to make BaSO4 barium sulfate. Another example. In this one, we have solid nickel 2 sulfite What's a net ionic equation? Now, if you get a question where they tell you straight away what the precipitate is, in this case, they're telling us it's solid nickel 2 sulfide. That makes it really easy to figure out what the net ionic equation is. They tell us NiS is the solid made. So really, just using some logic here, nickel plus sulfur makes NiS, or nickel sulfide. That's your net ionic equation right there. So in a question like this, where they tell you what the solid is, what the precipitate is, you actually don't have to do the steps that we did earlier. So going back to one of the previous problems, like this one right here, in this question, they actually told us what the solid was, barium sulfate. So we can actually figure out immediately that it's just BaSO4 to make BaSO4. So you don't actually have to do 1 and 2 with problems like this. If you do more advanced ionic equations like this, excuse me, my bad. If you do more advanced ionic equations like this, a lot of times what they'll do is they'll give you 2 reactants and they'll expect you to figure out what the solid is on your own.